Hello, 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 and welcome back for the second video on balancing, where we're going to be talking about composition and decomposition. Now, these are very easy at first glance, but they can get a little confusing, and I'm going to go down and do a third one with you to show you why. We start, though, the same way. Okay, we want to find the largest molecule, or the most complicated molecule. Now, in this case, it's a little harder, because in A, we have 1, 2, and 2. Well, which one of these do we start with? You start with the one that has a higher number in it. When you have this, you start with the one that has a higher number in it. Okay, so O2 has a higher number. This is more likely to actually be a 1. So we're going to put a 1 in every blank because I kind of skipped over that. This one is most likely to actually stay the 1. So O2, we find it over here. Well, we've only got 1, so this should be a 2. Cu also is now 2, so over here we need a 2. Easy. Okay, now we have H2O. Okay, we're going to again put 1s in each blank. H2O is the largest, so this is probably going to stay a 1. So we pick one. I'm going to go with H2 because it's at the beginning. So H2 is already balanced. Sweet. We don't have to change anything yet. O is not. Here, there's 2 oxygens. Here, there's only 1. That means we're actually going to have to change this number. This is not correct. It happens sometimes, but most of the time it works out better. So this cannot be a 1. Because we have 2 oxygens over here, we need 2 oxygens over here. So this is going to have to be a 2. And because this is a 2, that means our hydrogens are not balanced anymore. So this also has to be a 2. Okay? As you can see, these go pretty quick. Not too bad. Okay, I do want to go down, though, and look at one that's a little more complicated because it tends to throw people for a loop. Okay, we are going to... I should clear that. We are going to go down and look at reaction N, which is another composition reaction. Okay, now in this case, this is obviously the largest, Al2O3. So we would normally say, again, this is probably going to stay a 1. I'm going to tell you, this ain't a 1. The problem is oxygen. Here, we have a 2. Here, we have a 3. There is nothing we can do on this side, because we have to put whole numbers. There's nothing we can do on this side to get 3. And there is nothing we can do on this side to get 2. So we need to use what's called the least common multiple. A little bit of terminology from your math class. Okay, the least common multiple is the smallest thing that both 3 and 2 will divide into. Usually, that's going to be 3 times 2. And in this case, most of the time, it's going to be just whatever that multiplied is. Okay, so we want 6 on both sides. To do that, we have to swap these subscripts and make them coefficients. So this 3 is going to be the coefficient here, and this 2 is going to be the coefficient here. And then based on that, we now know that we have 4 aluminums, so we have to come up to the first one here and make that a 4. Okay, that is about the most complicated thing that you're going to run into on composition and decomposition. And this video was fairly short, but I'm going to go ahead and stop it here because I want to do combustion in its own video. So, have a wonderful whatever. I'll see y'all next time.